Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be going over today is how to do something called stoichiometry. This is probably one of the things that we've been really working towards this whole year. So go ahead and try that bell work question for me. It's at the top of your 11.1 notes page, and then come back and start paying attention to this video. So what we're going to talk about today is, again, stoichiometry. The things that you should know by the end of this video is, first of all, subobjective 1. You should be able to write the balanced chemical equation for a reaction. Again, something we did earlier in the year, be able to balance a reaction. Subobjective 2, find the mole ratios in a chemical equation. We'll talk about a mole ratio today. And then our goal is to be able to change the quantity of a given substance to a quantity of a desired substance using a chemical equation. So, just to review a lot of the stuff we've done this year, here's all the stuff that we've done this year. We've found properties of matter. We've talked about chemical and physical changes. We've solved a bunch of problems. We've talked about the structure of atoms, protons, neutrons, electrons. We've talked about the periodic table with periodic trends and electron configurations. We've calculated moles, grams, and particles. We've gotten the formulas and names for compounds and figured out how to write those. We've determined chemical bonding. We've talked about polar bonds and nonpolar bonds and ionic bonds and metallic bonds. We've written, we've balanced, and we've identified types of chemical reactions. That's pretty awesome. Like, just the amount of things that you guys have worked on this year, it is great. Okay? And all of that stuff has been stuff that we've been doing to prepare for this lesson. So, you guys, you're pretty good. You're not there yet, but you're doing a great job. So continue to keep up the good work and continue to learn this stuff. So here's the stuff that you've been waiting, really, that we've been preparing for all year. And it's this question. So this is really our goal. So our goal says to be able to change the quantity of a given substance to a quantity of a desired substance using a chemical equation. That's what this is. Okay, so here's our problem. It says, how many grams of sodium carbonate are produced when 2.49 grams of sodium chloride reacts with potassium carbonate? We're going to be able to solve this problem by the end of our lesson, and that is our goal for today. So, here we go. It looks pretty simple, but really it's taken us all year to get to where we are right now. So, here are things you should be able to do from this problem. You should be able to write the formulas for those names. So things like sodium carbonate and sodium chloride and potassium carbonate. You should be able to write those formulas. You should be able to balance that equation once you have it written. Then you should be able to calculate the quantities. For instance, it says you have 2.49 grams of sodium chloride. You should be able to change that to other quantities. But the difficulty, the thing that you might be struggling with is, how do I change grams of one substance to grams of another substance? What's that conversion? We've been talking about conversions. So how do you make that conversion? The key to that conversion is having the balanced equation. Now, I call that Moletown, okay? Because a balanced equation gives us the mole amounts of each substance. Okay? That's how you can find the quantities of reactants and products, is you have to change to moles. That is something that you should ingrain in your mind. Anytime you're doing stoichiometry, you have to change to moles. Okay? But the only way you can do that, you can only do that if you get to the balanced equation, which is Moletown, the mole ratios. Okay? So here are some questions that are similar to what I'm asking. So in our example problem, our goal problem, I'm asking you to change from grams of one substance to grams of another substance. That's kind of like these questions. I'm saying, how much peanut butter do I need to make a certain number of sandwiches? So I'm saying, here's how many sandwiches you need to make, 12. Okay? How much peanut butter do I need? So I'm asking you to change from sandwiches to an amount of peanut butter. Okay? If I have 2 eggs, how many dozen cookies can I make? So I'm asking you to change from a certain number of eggs to a certain number of cookies. That's from one quantity of one substance to a quantity of another. How much flour would it take to go with 4 cups of sugar when I make a cake. Okay, I'm asking you to convert from cups of sugar to how much flour you're going to need. Okay, we're changing units. That's the same thing that we're going to be doing in this process. But when we do it in chemistry, it's called stoichiometry. Okay? Stoichiometry, this is the definition of it. It's the process of going from the quantity of one substance, your substance you're given, okay, you're going to be given information, you're going to change it from the quantity of that substance to the desired quantity of another substance, and it's going to use a chemical reaction or a chemical equation. Okay? Don't forget, you have to get to moles. You have to get to mole town, which is that balanced equation. You cannot do stoichiometry without having a balanced chemical equation. Remember that. So, here's how you interpret a balanced equation. Okay, now, on your notes page, you're going to have a bunch of blanks to fill in. You can fill those in. Really, like, the important thing to remember, okay, isn't that you just copy all this stuff down. The important thing to know is this, what's in red. Okay, now, notice how I have the number of atoms. So AgNO3 and this 2 in front, what that means is I need 2 of those molecules. I need 2 molecules of AgNO3 to react with 1 molecule of CuCl2 to make 1 molecule of CuNO32 and 2 molecules of AgCl. That's super important. We've talked about molecules. So notice how 2 molecules, 1 molecule, 1 molecule, 2 molecules. That ratio is also true of moles. These 2's here, we've been talking about moles. I could also say this another way. If I have 2 moles of AgNO3 and it reacts with 1 mole of CuCl2, I'm going to get 1 mole of CuNO32 and 2 moles of AgCl. Okay? Stoichiometry it's vital that you understand that. Now, what I'm showing you is that just because these 2's are the same does not mean their masses are the same. Because remember, a mole of AgNO3, if this 2 here means 2 moles, a mole of AgNO3 or 2 moles of AgNO3 does not weigh the same amount as 2 moles of AgCl because they have different molar masses. Okay? That's important and vital to remember. Again, if you're going to change from the quantity of one substance to the quantity of another substance, the first thing you have to do is balance the equation, get to moles. Okay? So, the key, again, to understanding this is that the coefficient, okay, remember the coefficient are these numbers in front, and remember when we don't write a coefficient, there's just a 1 there, okay? The coefficient in a balanced equation gives the relative amount in moles, not in grams, not in liters, okay? The relative amount in moles of reactants and products, okay? So, here's something that should look familiar to you. Looks kind of like our mole map, okay? This is a concept map. So, remember when we did our mole conversions, I would ask you guys to convert from grams of something to moles of something. Now, what I have here is a slash and then MMA. What MMA doesn't mean mixed martial arts. It means molar mass of substance A. So substance A could be any substance. Substance B over here, these B's could be any substance. Okay? All that I'm showing you is that if I have my grams of a substance and I divide by its molar mass, I get to moles of that substance. Or if I have particles of a substance, okay, and I divide by Avogadro's number, 6.02 times 10 to the 23rd, I will get to moles of that substance. Same thing for if I have a different substance, substance B, okay? If I know moles of B and I want to find grams of B, well, I'm going to multiply by the molar mass of B. That will get me to grams. If I have moles of B and I want to get to particles of B, I'm going to multiply by Avogadro's number, 6.02 times 10 to the 23rd. So this is a mole map. I want you to write this down on your notes. So just complete this, fill this in on your notes page. Here's the question though. How do I convert there? How do I get from moles of substance A to moles of substance B? Okay, because we can do this stuff. You should be able to. You should be able to convert from grams to moles to particles, no problem. Okay, you should be able to convert from grams to moles to particles, no problem. The difference is, how do I change from moles of one substance to moles of another substance? The answer to that lies in the balanced equation. That's why you have to have a balanced equation. So remember, the coefficients of substances in a chemical reaction represents the moles. If you can find the moles of substance, so substance A, then you can move to the moles of substance B using something called the mole ratio. Okay? The mole ratio. The mole ratio is the ratio of coefficients of substance B over substance A. This is the way we cross that bridge, okay, that red arrow I had on that last slide. How we cross that bridge to go from moles of A to moles of B is using the mole ratio of substance A and substance B. So whatever substance A's coefficient is and whatever substance B's coefficient is, I get those numbers, I can create something called the mole ratio, and that's how I can convert. Once we get to moles of B, then we just do our conversions just like normal. Okay? So, here's our steps. First step to doing stoichiometry. You have to write a balanced chemical equation. Has to be balanced. You have to make sure there's the same number of atoms on each side of the reaction. Step 2, you have to find the number of moles of the given substance. We're going to label that substance A. So it's like in your equation, I'm going to put like an A above what's given to me. Okay? That's our known substance. Then we're going to use the balanced equation to find the ratio of moles of the given substance, which will be given to us in the problem, that's why it's called the given, to moles of our needed substance. Needed substance is what we're going to be asked for. The thing that we are asked for in our chemical equation, we're going to label that substance B. Okay, so A is going to be what we're given, B is going to be what we're asked for. Then we're going to convert moles of our needed substance to whatever quantity is desired. So again, here's this mole map. Okay, we now have a conversion to go from moles of A to moles of B. Okay, so here's an example of a problem. You might be given grams of something, and it might ask you for grams of something else. You're going to use substance A, let's say it's CO2, and you're going to divide by the molar mass to get to moles of B. Then you're going to use something called the mole ratio. That's the B over A. So you're going to multiply by the conversion factor, again we talked about conversion factors, of B over A. B is going to be the coefficient of whatever substance B is in your equation. A is going to be whatever the coefficient is of substance A in your chemical equation. That's why it has to be balanced. That will allow you to convert to anything else of substance B. So let's go back to our question. So here was the goal of our notes today, the thing we were trying to accomplish. So the question we were given is, how many grams of sodium carbonate are produced when 2.49 grams of sodium chloride react with potassium carbonate? So the first thing that you need in order to do stoichiometry is you need a balanced chemical equation. So here's my chemical equation, and what I've done is I've gone ahead and balanced it for you. So again, what this means is these coefficients here mean the mole ratio. In other words, I have 1 mole, I would need 1 mole of potassium carbonate to react with 2 moles of sodium chloride to produce 1 mole of sodium carbonate and 2 moles of potassium chloride. That's what that means. That's what these coefficients mean. So what we're going to do here is, after we've got our balanced chemical equation, we need to identify what our given substance is. We're going to call that substance A. And what the substance we're trying to find, we're going to call that substance B. So again, how we identify substance A is that's what we're given information about. So we have 2.49 grams of sodium chloride. So you look on here and you find which one is sodium chloride. Well, that's NaCl. So NaCl is going to be our substance A. And then substance B is what the question asks us for. It says how many grams of sodium carbonate. So I'd find sodium carbonate on here. It's right there. So I'd label my A and I'd label my B. Okay? So then, after that, just like any of our other like mole conversion problems, I'm going to start with the information that I'm given with. I have 2.49 grams of sodium chloride. I'm going to start with that. Okay, I've got 2.49 grams of NaCl. Okay, now I'm going to go to my mole map. Okay, you should have been adjusting that mole map as you've gone through the notes. So I'm going to go back a slide here. This is what my mole map looks like. I'm in grams of A. How I know I'm in grams is because I was given grams, and it's my substance A because it's the thing I'm given information about. So that means NaCl, remember, was my substance A. I labeled that because I knew information about it. So basically on my mole map, I'm starting here. I'm in grams of A. Then I go, okay, what did the problem ask me to find? It asked me to find grams of sodium carbonate. And remember, I labeled sodium carbonate as substance B. So back to my mole map. I'm going to be going from grams of A to grams of B. And basically, I'm just going to do conversions to get from grams of A to moles of A, then from moles of A to moles of B using my mole ratio, then from moles of B to grams of B using my molar masses. Now, these molar masses here are not the same molar mass. This is the molar mass of substance A. So whatever my substance A is going to have a different molar mass than my substance B. Okay, so here we go. So I start with my 2.49 grams of NaCl. Well, based on my mole map, it says the first thing I need to do is I need to take my grams of A and I'm going to divide by my molar mass of A. Okay, so substance A is sodium chloride. So I'm going to divide by sodium chloride's molar mass. How I would write that out using dimensional analysis is I would put 1 mole of NaCl on top and NaCl's molar mass on bottom. Remember, molar mass is always measured in grams. I'm going to put that on the bottom. Again, what that does is that's going to cancel out these units. Now, if I stopped here, I would be in moles of NaCl. Okay, next step. Okay, if you look on your mole map, again, the next step is we are now in moles of A. So now I need to convert from moles of A to moles of B. That's where I use my mole ratio. And this is where the coefficients come in. I go, what's my coefficient of substance B? Well, there's no number here, which means it's a 1. So that means I have 1 mole of NaCl, or excuse me, 1 mole of sodium carbonate for every 2 moles of sodium chloride. Okay? So I've got 1 mole of sodium carbonate for every 2 moles of NaCl. And again, it goes B over A. So that's why I put 1 mole of Na2CO3 on top, because that's my substance B, and it's B over A, which is 2 moles of NaCl. 2 moles of NaCl is going to go on the bottom. Okay? I want you guys to think about what's another mole ratio here. Okay? You're going to have some options. I want you to select what's another correct mole ratio. Okay, I've got, I guess, just to give you one, I have 1 mole of K2CO3 for every 2 moles of NaCl. Select another mole ratio from these options. Okay, so hopefully you've got the idea of mole ratio. That's how I get it. It's based on what I'm trying to find over what I'm given. Okay? So now if I went back to my mole map, using that mole ratio, I'm going to convert from moles of A to moles of B. Now the next step I do is now I need to convert from moles of B to grams of B, because that's what it asked me to find. So I am right here. My moles of NaCl are going to cancel out. Now I need to change from moles of substance B to grams of substance B. In order to do that, if you look at your mole map, it says that I need to multiply by the molar mass of substance B. Well, substance B is Na2CO3. So I'd figure out its molar mass, and I'm going to multiply by it, so that means it's going to go on top. Na2CO3's molar mass is 105.99. So, and that's going to go over 1 mole of the sodium carbonate. Then, notice how my moles of Na2CO3 cancel out. The only unit that I have left is grams of Na2CO3, and that's what it asked me to find. It says how many grams of sodium carbonate are produced. So all I'd have to do for my math here, okay, my units have all canceled out. This is going to be my unit. To find my number, remember in dimensional analysis, we divide by numbers that are on the bottom of fractions, and we multiply by numbers that are on the top. So I'd start with my 2.49. I would divide by 58.44 because it's on the bottom. Then I would multiply by 1 over 2, or multiply by 1/2. Multiply by 1, divide by 2. Then I'd multiply by 105.99, and that answer would give me this. In other words, if I ran this reaction and I started with 2.49 grams of sodium chloride, I should produce 2.26 grams of sodium carbonate. Okay? We're going to try another one. Okay, we'll walk through it again, just like this one. Okay, make sure you're paying attention. So, here's another question. It says, what mass of lead 2 nitrate is required to react with sodium iodide to produce 2 grams of lead 2 iodide and sodium nitrate? So again, the first thing we need is chemical equation, and we need it balanced. So here's my chemical equation. Sometimes I might ask you to produce the chemical equation for me. Now again, how we would do that is we'd go, oh, lead 2 nitrate. Remember when we did our naming and writing formulas section? You'd have to take that name and write the formula. Then I took sodium iodide, took that name, wrote the formula. It said to produce, which means I've got my reaction, my arrow, and it's going to produce lead 2 iodide. That's the formula for lead 2 iodide. And sodium nitrate. That's the formula for sodium nitrate. Now I need to balance. Okay? So I've got 2 nitrates on the left, and I only have 1 on the right. So I need to put a 2 right here. Then, because I put a 2 in front of the Na here, that gives me 2 sodiums on the right, so I needed a 2 on the left. This is my balanced chemical equation. Okay, so that's step 1. Step 2, identify what I'm given and what I need to find, and label those as substance A and substance B. Okay, substance A is what I'm given. So what I'm given is I need to produce 2 grams of lead 2 iodide. So my substance A is going to be lead 2 iodide. Well, lead 2 iodide is right here. That's substance A. My substance B is what it asked me to find. It said what mass of lead 2 nitrate. So it's asking me about lead 2 nitrate. This is lead 2 nitrate, so that's going to be my substance B. Here's what I want you to notice. On the previous problem, my substance A was on the left side and my substance B was on the right. A and B do not always have to be on opposite sides of the reaction. This could have been my substance A and this could have been my substance B. It doesn't matter. A and B could be on both the same side of the reaction. They could be on opposite sides of the reaction. It does not matter. Okay, so this is what I'm given. This is what I'm looking for. So I start with my information that I'm given about lead 2 iodide. And I want to produce 2 grams of it. So I'm going to start with my 2 grams of lead 2 iodide. Then if I look at my mole map, okay, it says to go from, since I'm given grams of A, this is 2 grams, to change to moles of A, I need to divide by the molar mass. So I need to look up the molar mass of lead 2 iodide. So calculated the molar mass of that, and I got its molar mass to be 461.01 grams. So because it says to divide by the molar mass, again, to change grams to moles, we divide by the molar mass. This is the molar mass. I've got the molar mass on bottom, so I'm going to be dividing by it. Notice how my grams of lead 2 iodide are going to cancel. So that's now I'm in moles of A. Okay, I'd be in moles of lead 2 iodide. Next step is now I multiply by the mole ratio. Okay, what is B over A? Well, substance B is this. Its coefficient is 1. So I have 1 mole of lead 2 iodide, or excuse me, 1 mole of lead 2 nitrate for every 1 mole of lead 2 iodide. And again, it's B over A. So that's going to be 1 mole of lead 2 nitrate over 1 mole of lead 2 iodide. Now, now my units here would cancel. So now I would be in moles of lead 2 nitrate, which is moles of B. So I'm in moles of B on my mole map. Now I need to convert to, it says what mass, so I need to convert to grams of B. To convert to grams of B, I need to multiply by the molar mass of substance B. All right? So, again, if I went back and looked at my mole map, first thing that I did is I took grams of A, changed to moles of A by dividing by the molar mass. That was my first conversion. Second conversion is B over A, moles of B over moles of A. Third conversion is multiply by the molar mass of substance B. So it's going to look like So I need to find the molar mass of lead-2 nitrate. I did that. These units are going to cancel. So my unit will be grams of lead-2 nitrate, which is what it asked me for. It says what mass of lead-2 nitrate. Then I need to find my number. So to find my number, I'm going to do 2 divided by 461.01. Now because these are both 1 over 1, I don't do anything because it'd be times 1 divided by 1. That's not going to do anything to my number. Then I would multiply by 331.2. So again, anytime you see a 1, you don't need to multiply or divide by that number because it's not going to do anything to your answer. Okay? And what I should get is 1.44 grams of lead-2 nitrate. Okay? So now that's the kind of the 2 example problems that I have. Try some problems on your own at the bottom of your page. You can check your answers in this video and see how you're doing. Make sure you ask me some questions. If you have any questions, make sure you ask. This is a difficult unit, okay, and it really sets the groundwork for a lot of stuff we're going to do later on. So it's really important that you ask questions, and I'm eager to help you guys because I know this is difficult stuff. One thing I forgot to let you have you guys do is you're supposed to copy down this mole map again at the bottom of your notes. This is kind of the roadmap to how to do some of the problems you're going to do with stoichiometry. So make sure you pause this video, get this down. Again, what it's showing you is how to convert from mass or moles, or excuse me, mass of A, particles of A, or moles of A. Depending on what unit you're given, depends on where you start on this mole map. You'll start over here on the left side. Then, whatever the problem asks you to find, if it asks you to find mass of another substance, then you'd go to substance mass of B. If it asks you to find moles of substance B, then you'd go to this spot. If it asks you to find particles of substance B, then you'd go here. So take some time to copy that down so that way you have it on your notes. All right? Thanks for watching.